Hello everyone, this is Anil Reddy, Assistant Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today I am going to explain about numerical integration. There are several methods in numerical integration: trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule. If f of x is a differential function whose derivative is f of x, then integral a to b f of x dx is equal to f of b minus f of a. So this is called fundamental theorem of calculus. Most of the integrals can be evaluated by using this formula. However, in many applications or many integrals cannot be evaluated using this formula. For example, if I take the integral I is equal to integral e power minus x square into dx. This integral cannot be evaluated by using analytical method. So we use numerical method to find the solution of this problem. Similarly, if I write I is equal to integral sine root x dx. So this is also not possible to find solution for this integral using analytical method. So we use numerical integration method to find the solution for this integral. So to overcome this drawback, we use numerical integration methods. So that is, in numerical integration, the range of the integration is b minus a. So I will explain graphically. This is x-axis and this is y-axis. Now I take a is a coordinate on x-axis and b is the another coordinate. Now draw a curve. So the area under the curve. So numerical integration, the range of integration b minus a is divided into finite number of intervals. So that means, so the area under the curve, the area under the curve from a to b. So this is integral a to b f of x dx. So our target is to find integral a to b f of x dx. So which means the area under the curve from a to b. And now the range of this integration is b minus a. So this is b minus a. And this can be divided into equal number of intervals. So the integration techniques consists of equal number of intervals. So that is, we can divide this as equal number of intervals. This is x0. I am taking x1 and corresponding y0, y1, and x2, y2, x3, y3. Right. So this is the, we are dividing the equal intervals. So this is x0 and x1 interval, x0, x1 minus x0, x1 minus x0, and this is also equal, dividing with the equal intervals. So this is we take as a and this is b. Now we are dividing the area under the curve from a to b into equal number of intervals. So the integration technique consists of equal intervals. So based on the formulas known as Newton's Cotes quadrature formula. Newton's Cotes quadrature formula. Using this Newton's Cotes quadrature formula, there are several methods of integration. So your trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So using these methods to find the solution of the given integral. Now trapezoidal rule. The trapezoidal rule is a numerical integration method, and this is used to find approximate value of definite integral a to b f of x dx. And this numerical using this numerical methods, we can find this trapezoidal rule numerical integration or numerical quadrature formula. So by substituting, by taking n is equal to 1 in Newton's Cotes quadrature formula, we get trapezoidal rule. So by taking n is equal to 2 in Newton's Cotes quadrature formula, we get Simpson's 1/3 rule, and taking n is equal to 3, we get a Simpson's 3/8 rule. So one by one we'll see. Trapezoidal rule formula is given by integral a to b, or we can take x0 to xn. So integral a to b, here I am taking a to b, f of x dx is equal to h by 2, h is the interval difference, h by 2 into sum of the first and last ordinate y0 plus yn plus 2 times remaining ordinates y1 plus y2 plus y3 and so on up to yn minus 1. So this is called trapezoidal rule. Similarly, we can derive Simpson's 1/3 rule. So integral a to b f of x dx is equal to h by 3 into sum of the first and last ordinate, that is y0 plus yn plus 2 into sum of the even ordinates y2 plus y4 plus y6 and so on yn minus 2 plus 4 times odd ordinates y1 plus y3 plus y5 and so on yn minus 1. So this is called Simpson's 1/3 rule. So similarly, we can write Simpson's 3/8 rule. So how we get this? By taking n is equal to 3 or n is equal to 3, substituting in Newton Cotes quadrature formula, we get this Simpson's 3/8 rule. So that is integral a to b f of x dx is equal to 3h by 8 y0 sum of the first and last ordinate y0 plus yn plus 2 into multiples of 3 y3 plus y6 y9 and so on yn minus 3 plus 3 times remaining ordinate, that is y1 plus y2 and then y4, because already we have written y3 here, y4 y5 and so on. So this is called Simpson's 3/8 rule. So using these formulas, we can find the solution of the given integral. So example, evaluate integral 0 to 1 by 1 plus x dx by using trapezoidal rule, Simpson's 1/3 and Simpson's 3/8 rule. So here f of x is equal to 1 by 1 plus x and a is equal to integral lower limit a is equal to 0 and b is equal to, I am taking 1, and interval difference h is equal to b minus a by n. So the interval is we are taking the length of the interval b minus a, and it is divided into equal number of intervals by n. So interval difference h is equal to b minus a by n. So this is equal to 1 minus 0 by what is n here. So we can take multiples of 3. So here I am taking n is equal to 6. Now h is equal to 1 by 6. Interval difference is 1 by 6. Now we have to construct the table corresponding x and y values. So here x values are 0, 1 by 6 and 2 by 6, 3 by 6, 4 by 6 and 5 by 6 and 6 by 6, it is equal to 1. So the range of the interval is 0 to 1. Now corresponding y values, by substituting 0 in this equation, y is equal to 1 by 1 plus x, will get 1, and if we substitute x is equal to 1 by 6 in this equation, will get 0.8571. So like that we will get the corresponding y values. Now we will find trapezoidal rule. First one, trapezoidal rule. So what is the formula for trapezoidal rule? Integral 0 to 1 f of x dx is equal to h by 2 y0 plus yn plus here we take y0 and this is y1, y2, y3, y4, y5 and y6 So we take y naught plus sum of the first and last ordinaries was 6, y naught plus y6 plus 2 into remaining ordinates, that is y1 plus y2 plus y3 plus y4 and y5, because already we have written y6 here. So this is equal to, what is the h? H is the interval difference, that is 1 by 6. So already 1 by 2 into 1 by 6. Y naught value is 1 plus y6 value 0.5 plus 2 into y1 plus y2. So 0.8571 plus 0.75 plus 0.666 plus 0.6 and 0.5454. So by evaluating this, we get the answer as 0.6948. So we get a 0.6948 by evaluating this integral. Now we'll see the second one, Simpson's 1 by 3 rule. Simpson's 1/3 rule. Integral 0 to 1 f of x dx is equal to h by 3 y naught plus y6 plus sum of the even ordinate 2 into y2 plus y4 plus y6 already we have written, so y2 plus y4 plus 4 into sum of the odd ordinates. So what are they? y1 plus y3 plus y5. Now substitute the values here. H value is, so h value is what? 1 by 6, so that is 1 by 3 into 6 into y naught. Y naught value is 1 plus and y6 0.5 plus 2 into y2 0.75 plus y4 0.6 plus 4 into y1 0.8571 plus y3 0.6666 plus y5 0.5454. So now if we evaluate this, we can get the answer as 0.6931. Similarly, we can find Simpson's 3 by 8 rule. Simpson's 3 by 8 rule. So integral 0 to 1 f of x dx is equal to 3h by 8 into y naught plus y6 plus 2 times y3 plus only y3, because already we have written y6 here, plus 3 into y1 plus y2 plus y4, because y4 is okay, y4 and y5. So now substitute the values here. 3 into h is 1 by 6, so 8 into 6, y naught 1 plus 0.5 plus 2 into y3. Y3 value is 0.6666 plus 3 into y1 0.8571 plus y2. Y2 value is 0.75 plus y4 0.6 plus y5 0.5454. Now this, by simplifying this, we get 0.6932. In today's session, we have discussed numerical integration using trapezoidal rule and Simpson's 1/3 rule and Simpson's 3/8 rule. In the next session, we will discuss numerical solution of ordinary differential equations. So that is Taylor series, Euler's, modified Euler's, and RK method. Thank you.